Hi everyone, my name is Emily, and with the help of my partner Evelyn, we researched the air quality in China and analyzed the effect COVID-19 had on some of China's most influential cities during and after the lockdown. The picture provided is a quick overview detected from NASA and the European Space Agency of China's nitrogen dioxide production from the beginning to about a month into their lockdown, which will be actually later explored in our presentation. So the title of our article is 4-Month Changes in Air Quality During and After the COVID-19 Lockdown in 6 Megacities in China. The name of the 9 authors and contributors are stated below. And in conducting research, the 6 megacities focused on were Beijing, Chengdu, Shenzhen, Xi'an, Shanghai, and Wuhan. In this experiment, research was conducted as naturally controlled. It is defined as such because lower air pollutants were expected due to the lower pace of human activity in these cities from the lockdown. From the data, meteorological conditions and atmospheric chemistry were also examined, and machine learning techniques were also utilized to analyze any changes in air quality of these cities. According to MathWorks, machine learning techniques are essentially a form of artificial intelligence through which computer algorithms analyze and allow systems to automatically learn without necessarily needing to program them. So this just allows the machine to learn from the data itself that it collects. So this research is important because it's essential that we research China in regards to the coronavirus outbreak, as the first known case originated in this country. Investigations conducted by Chinese authorities identified that the first known case was in late December of 2019, and it was linked to a wholesale food market in Wuhan, which is actually one of the 6 cities we'll focus on. China was also the first country to implement these serious lockdown restrictions, and going off some key milestones in the spread of the pandemic provided by the World Economic Forum, the first death was reported in January, and Wuhan was placed under quarantine with rail and air services suspended. As we know, these restrictions would later apply to the country as a whole. Therefore, we should research China throughout this process, as data from their lockdown could potentially predict results for future countries attempting to also lower their COVID cases or just improve air quality in general as well. In conducting research, emission sources and pollution concentrations were compared in different climate zones between the cities. In suburban and urban areas, traffic changes and the poor air quality was compared, which leads researchers to question just how much of this improvement of air quality was due to the lockdown itself and how much was due to restrictive measures. So during this time, researchers analyzed air quality and concentration productions during the restrictive period as well as after. One of the main findings was that the lockdowns indicated that a decrease in nitrogen dioxide NO2 concentrations would lead to an increase in ozone O3 concentrations. And as stated in the article, NO2 concentrations are more directly associated with emissions. So this correlation could be granted due to the fact that it's a gaseous pollutant composed of nitrogen and oxygen, which according to the Environmental Protection Agency, this can form from emission from cars, trucks, buses, etc. So now in analyzing the emission sources and pollution concentrations, the researchers used reported hourly concentrations of NO2, O3, PM2.5, which this just measures the particles formed as a result of burning fuel and any chemical reactions that occur in the atmosphere, and carbon monoxide, which is actually present in Earth's atmosphere at low concentrations. So these concentrations are all dependent variables, and the time was the independent variable. And looking at this data table 1 regarding the relative change during the observed and predicted concentration under the lockdown scenario between these different periods, we have the different periods of the Spring Festival Week, the prolonged holiday week, under level 1 COVID-19 control actions, and after level 1 COVID control actions, which we should keep in mind are the same as the restrictive period and the quarantine itself. And these relative concentrations are all given according to each of the 6 megacities. These amounts are reported with daily changes, and the values are given as a coefficient of determination, as we can see in these numbers. What this is, just a measurement to explain how much the variability of one factor can be caused by its relationship to another. As we can also see, the coefficients are given with plus or minus symbols, and these are solely used as more or less indications, kind of like estimates. Using this data table, we can actually see that with the lockdowns, a decrease in NO2 concentrations would in fact lead to an increase in O3 concentrations. So for example, if we take advantage of Beijing here, we see that its coefficient of determination for NO2 during the Spring Festival week is negative 28.8 plus or minus 11.8. And now if we jump down to Beijing, while it was in the level 1 control action period, we see that it's actually negative 44.9 plus or minus 20.4. So the NO2 concentration does indeed decrease. The lockdowns also led to decreases in PM2.5 and CO concentrations, but these reductions in general were a bit less significant, as researchers mostly wanted to focus on NO2 concentrations as well as O3 concentrations. So now if we take advantage of Shenzhen, for example, and we look at its O3 concentration, we can see that during this time, during the Spring Festival week, its O3 concentration is negative 7.4 plus or minus 6.9. And then if we're jumping down under the level 1 control actions, we see that it's 2.8 plus or minus 20.2, which does in fact increase. So thus, the effects of the level 1 control actions as shown in this data table do approve the finding that during the restrictive period, this leads to the decrease of reduced NO2 concentrations, meanwhile in an increase in O3 concentrations, just looking at Beijing and Shenzhen, for example. Studying traffic emission changes in Beijing and Chengdu, the lockdown period was utilized to monitor traffic conditions in these two cities. The average measured and predicted patterns of NO2 concentrations were compared, and this research would contribute to any changes in observed concentrations of other urban areas. Specifically, these two cities were chosen because they are more developed in comparison to the other cities researched. Recorded data allowed for the monitoring of the dynamics of traffic conditions throughout the entire lockdown period in Beijing and Chengdu. And if we take a look at the graphs comparing the hourly and about 2-week difference in NO2 concentrations in these two cities, we can see that traffic emissions slowly rebounded once restrictions were lifted in some areas. So for example, during the week of February 24th, Beijing was still enforcing the most stringent level 1 controls, and their daily NO2 emissions were actually reduced by 45%. Now, in contrast, during this same week in Chengdu, they had lifted their level 1 control actions, and they had an increasing number of people that began to commute normally again. So as a result of this, the daily NO2 emissions in this city were estimated to only be about 22% lower than the pre-festival levels, which were long before the restricted period, which basically indicated that there was no progress at all or very minimal progress. So the lockdown itself resulted in about a 35 to 53% decrease in NO2 concentrations during the restrictive period, while higher O3 concentrations did occur. This contributes to the major finding that traffic emissions dominate the total NO2 production in urban areas such as Beijing and Chengdu.
Overall air quality changes during both lockdown period and lifted restrictions. This figure represents the overall air quality changes throughout the months of January through April of the pandemic. There are various colors, percents, and numbers depicted that I will go over in the next slide. The main takeaways are the yellow and green areas on the graphs. These depict the level 1 lockdown periods and the periods directly after restrictions were lifted, respectively. Although each graph is unique, including the duration of some of the time periods, all the graphs show a consistency in NO2 reduction patterns, regardless of different climates, urbanity, and traffic sites. I'm just going to go ahead and use the graph of Xeon as an example to explain all the different colors and bars represented on all the graphs. All 6 megacities were broken down into the same 5 time periods. White, or before Spring Festival, lasting between January 1st through January 20th. Pink, Spring Festival, lasting between January 24th and January 30th. And purple, being Holiday Week, lasting from January 31st through February 9th. Yellow, being the level 1 COVID control, varied by each city. Green is the period after lifting level 1 controls and is also varied depending on the city. The green bars represent the predicted NO2 concentrations without lockdown scenario, gathered using meteorological data from 2019. The red bars represent the observed NO2 concentrations during the pandemic, gathered using meteorological data from 2020. The percents above are the relative differences between observed and predicted NO2 concentrations. The main takeaway from this figure and data is that level 1 lockdown controls were so strict on commercial and industrial activities that it directly led to a decline in traffic. Traffic in the forms of buses, cars, and trains were significantly monitored and reduced, if not completely halted. This decline in traffic was directly correlated to the decrease of NO2 concentrations. The decrease in NO2 concentrations caused an increase in the ozone concentrations, or O3. The increase of O3 was a nonlinear response to the reductions in the pollutant emissions and the forms of NO2. This is called atmospheric oxidizing capacity. In other words, this is the atmosphere's way of self-cleansing by releasing O3. This article originally grasped our attention because it was about something positive that arose from this pandemic. We were also intrigued because China has a reputation of having one of the worst air qualities in the world. Therefore, if a pandemic could help better qualify the air of a country who is known for its bad air quality, what could it do for the rest of the world? The authors of this article did a good job at explaining their data and breaking it down in a way the general public could understand. However, as we researched further, we realized the authors just took government data from seemingly trustable websites, such as the National Chinese Environmental Monitoring Center and the National Oceanic and Atmospheric Administration database, and analyzed it and grouped it into figures. They did a good job at explaining the data, yet our concern is that they didn't actually conduct any research themselves. They never gathered any data themselves to corroborate what they published. They simply trusted in the data that they found. Because this was concerning, we researched the topic further and found a similar article to analyze. The article's name was Airborne Nitrogen Dioxide Plummets Over China. Now, this article comes from NASA, so you know that they did their homework before publishing an article. The two articles generally have the same main areas of focus, including a dramatic decrease in NO2 density. However, in the article by NASA, they were able to get their own data using NASA's AURA satellite. Another topic in common was the increase in O3 concentrations as a result of a decrease in NO2 concentrations. In this case, NASA was also able to gather their own data using NASA's Ozone Monitoring Instrument, or OMI. In addition to gathering their own data, NASA's article also provided more information that helped clarify some topics, such as that another reason 2020 data might be lower than that of 2019 is because China has been enforcing new environmental regulations over the past couple years. Another topic the second article researched into more was that the purple time period of the prolonged holiday week includes celebrations of Lunar New Year. Lunar New Year celebrations usually make businesses and factories close from the last week in January into early February. Previous observations show that air pollution usually decreases during this period and then increases once the celebrations are over. This is based on OMI data gathered between 2005 and 2019. So not only did the second article publish data that they gathered themselves, they had data from a much longer time period to corroborate their findings, and they further analyzed other contributing factors. However, both articles concluded that 1, 2020 data showed a significantly lower NO2 concentration than previous years, and 2, 2020 data also shows that the reduction rate is more significant than in past years and has lasted significantly longer. Overall, the Airborne Nitrogen Dioxide Plummets Over China article was easier to trust simply because they had conducted their own research and their data corroborated their findings. However, the main findings were the same for both articles. In conclusion, Emily and I decided that the major findings were that the lockdown on megacities in China led to significant reductions in NO2 concentrations during the highest period of level 1 controls. And although this varied by city, the values were between 36 to 53% lower than the predicted NO2 values during the without lockdown scenario based on 2019 data. Especially in the cities of Beijing and Chengdu, the most urban cities, where the extensive traffic decline proved to be huge factors in the decrease of NO2 concentrations and therefore the increase in O3 concentrations. Another important thing to note was that the increase in O3 concentrations during the same periods in which NO2 concentrations were the lowest. The decreased NO2 concentrations were directly comparable to how long the level 1 controls lasted in each city. After the level 1 controls were lifted in Chengdu, Shanghai, Shenzhen, and Xi'an, the NO2 levels were below 10%, compared to the above-mentioned 36 to 53% decrease during the level 1 control periods. And the last major finding is that the reduction of NO2 concentrations are directly correlated to the level 1 lockdowns, strict controls on activities, and therefore vehicular traffic. Overall, Emily and I really enjoyed learning about something positive that came out of this pandemic, and we hope that you enjoyed our presentation. Here is a list of references we used if you're interested in more information or want to research the topic yourself. Thank you for watching.